Hello everyone, and today in this video I will try to give a basic introduction related to the topic of gravitation, and which is very important, and which was responsible for humans exploring the other planets like Moon, Mars, etc. Okay, so our main discussion in this video will only be the importance of gravitation and what makes it very different from the other subjects in physics, and why is it very important to somebody who wants to pursue a higher degree in physics. Okay, and this is also this subject will also be familiar to a intermediate student who is preparing either for their board exams or preparing for entrance examinations like JEE mains and advanced. But in this I don't want to make the things complicated in this video. I just want it to be an introductory video for the gravitation, and in the subsequent videos or in the upcoming videos I will try to discuss different topics and concepts related to the gravitation. So assume this as an introductory video to my channel and as well as to the gravitation. Okay, and first important thing is I would like to discuss how I will be making the videos on my channel. First and second video will be purely dedicated to the concepts every week, and first and second day it will be dedicated to the concepts of the particular topic, and then the third day I will be dedicating a video to different concepts and applications, or how to solve different kind of problems related to the concepts discussed in the previous 2 days. Okay, this loop continues, so every first second, so if I make 2 videos on concepts, the next third video will be related to the applications and examples. So this process continues. So now I've picked the gravitation as the first topic in order to proceed with the subject, because I think gravitation is very important topic, and the topic I like the most. So now let's get into the topic, and we'll not discuss much of the things. We'll discuss the importance of gravitation and why we must study the gravitation, and as well as the universal law of gravitation in this video. And first thing, whenever we say the word gravitation, Newton definitely comes to our mind, right? Because everybody knows the story that when the Newton was sitting under an apple tree, and an apple fell from the tree to the ground, and that apple made him realize or formulate the concept of universal law of gravitation. So that's why everybody is familiar with this, but most of us are not familiar with the law of gravitation proposed by him, which we will be discussing in the video in a short while. But before going to that, important question that must be asked: why we must learn gravitation? So an important question that must be asked, and an important question that's ignored most of the times. So why we should really learn gravitation? Okay, let's imagine this world where we are living. It's not an imagination. Let's take the world where we are living on the planet Earth, and we do so many things every day. We go to school, we come back from school, we play different games: cricket, basketball, and football, hockey, tennis, shuttlecock, and so on. So many games. And we eat, we sleep, and we do so many things. We push things, we play with things, and so on. So these are all possible just because of this thing called the gravitation, the force of attraction possible between two masses. Okay, suppose, imagine your life. Every day you lead your life, you can stand on a ground firmly, and you are stable whenever you stand on the ground. But imagine your life without gravitation. So when there is no gravitation, you can't actually stand on the ground. You keep floating around everywhere. So you may not be permanently situated on the earth. Okay, if the gravitation were not possible. Try to imagine this. Try to think of the world where there is no gravitation, where objects are floating around everywhere. So when I push this boat, No, because of gravitation, even if I'm applying some force, it is able to stay here. If gravitation was not possible, this could have floated around somewhere. Now, when I throw this marker upwards and it's coming downwards, thanks to the gravitation. Otherwise, it could have gone upwards, and so on. And also, when you play football, so when you kick a football, it goes up and falls down. So thanks to the gravitation again. Otherwise, that could not have been possible. So we come across this concept of the gravitation in our life everywhere. But this is not much of importance, because we need not study about the gravitation in order to live every day. But it's there and it's helping us in every possible way. And that's the only reason that we are alive. And that's the only reason that we are able to stand, walk, run and do all the things which we do every day. And that's what happens when there is no gravitation. And why should we study as a student? Why should we study this topic as a student? First important thing. So, if you are a student of science background, so if you go to the higher studies, gravitation comes across everywhere. So, if you take physics, higher standard physics, so gravitation is definitely involved. If you take some physics or some engineering where you deal with machines, or where you deal with cars, okay, trains, or where you mostly with rockets, aeroplanes, okay. So all the times gravitation is involved everywhere, okay. So it's very important to learn the gravitation. And where do we use this gravitation in the technology? For example, so when you want to launch a rocket, the most important thing you want to study is the gravitation. So if you have no idea of gravitation, there is no way you can design a rocket. There is no way you can find your requirements for a rocket and so on. And then, so why do we design rockets? In order to launch satellites. So we design rockets. Rockets are the vehicles for transporting satellites into the outer space, as buses are the vehicles to transport humans from home to school or home to office. Similarly, rockets are the transportation vehicles for the satellites. So even the satellites which revolve around the earth, around moon, or around another celestial objects, so gravitation is definitely required. So even the satellites require the gravitation, like so you need gravitation in order to launch a rocket. I mean, you should have the idea of the gravitation in order to build a specific kind of rocket. So you need to understand the gravitation in order to make the satellites rotate around the planet. And so satellites could either be natural satellites or artificial satellites. And natural satellites. Our natural satellite is moon. So because of the gravitation, the satellite, our natural satellite moon, is able to go around earth. If this is earth, the moon is going around the earth, so all the time, because of the gravitational force of attraction acting on the moon towards earth. So what causes that moon to rotate around the earth, we'll be discussing in the upcoming videos, but gravitation is what causes it to rotate. But how it does, we will discuss in the subsequent videos. And artificial satellites, we apply the same mechanism used by the moon in order to rotate around the earth to make the satellites revolve around the artificial satellites revolve around the earth. Even earth is able to revolve around the sun because of the gravitational force acting between the earth and sun. So this is how the gravitation concept, or the phenomena of gravitation, very important. So when it comes to the existence of the universe, so we can't imagine a universe without the presence of gravitation. So gravitation is what holds everything together and what's making this life possible. Okay, that's the importance of gravitation. So, and these are the uses or importance of the gravitation. And that's it. Now we will proceed to the universal law of gravitation proposed by the Newton. So we'll proceed to the Newton's law of gravitation, what Newton proposed under his Newton's law of gravitation. Or we cannot simply call it universal law of gravitation, but I would also like to call it Newton's law of gravitation, because he was the one who proposed it. So next, and what's gravitation? I said it's very important to us. Why is it very important to us? I've also explained, but how is it very important? Now let's try to understand the phenomena of gravitation. Let's say we have two masses, m1 and m2. m1 and m2, two masses. Let's assume these to be the point masses. Okay, to avoid confusion, let me take them as 2 points. Okay, the concept of point masses is very important in physics. It plays a very great role. Point masses. So what do I mean by point masses? Those masses whose size can be thought of as negligible, whose size can be neglected. Okay, such kind of masses can be considered as the point masses. Or something like whenever you have two masses or small masses or very far away from each other, then in such a situation, when compared with the separation between them, their sizes can be neglected. Okay, the sizes can be neglected. Let's say we have 2 point masses, m1 and m2, point masses. I am telling this once again, those masses whose size can be neglected. So I have two masses, m1 and m2, separated by certain distance. Okay, distance, I'll take that to be d. Here d is the separation between these two masses, m1 and m2. Here d stands for distance. Okay, so d is the distance between these two masses, m1 and m2. Definitely when you place these two masses separately, okay, somebody has to hold them, because if you don't hold them, they'll definitely come closer to each other. Let's say let's say by some means we were able to hold these two masses, m1 and m2, away from each other by a distance d. Okay, now because both the bodies having some mass, they try to attract each other. So they try to attract each other because of the presence of mass. So that phenomena of attraction between two bodies, because of the presence of mass, is called gravitation. So gravitation is a phenomena. So gravitation is a phenomena, or something like a basic law which is obeyed by all the masses. Or gravitation is a phenomena which is obeyed by all the masses, or which is experienced by all the bodies which have mass, whatever the mass is. So that phenomena is called gravitation. Okay, the phenomena is gravitation. Now we will try to understand this phenomena using the law of gravitation, or the universal law of gravitation. Now we have these two masses, m1 and m2, separated by this distance d. So let's say we are in some intergalactic space, or away from each other in outer space. Okay, outer space. Then in such a situation, when you hold these two masses away from each other by a distance d, then these two masses attract each other. These two masses try to attract each other. So this mass m1 tries to pull m2 towards itself in this direction. So m2 tries to move in the left direction, or tries to move towards m1, and at the same time m1 experiences a force due to m2 in the right direction. Okay, this is what I mean by they try to attract each other. m1 tries to move towards m2, and at the same time m2 tries to go towards m1. So this is what I mean by trying to attract each other. So they definitely attract each other. So whatever the separation between them is, if it's small, or a moderate value, or a very large value, the force of attraction, since they are trying to move each other, we can call this force an attractive force. So this force of attraction will act between the masses regardless of the separation between them. So it does not matter whether separation is small or moderate or a very large value. This force of gravitation will definitely act between them if they have the masses. Okay, so the m1 tries to get attracted to m2, or m1 tries to move towards m2, and m2 tries to move towards m1. They move towards each other. Okay, Now in this situation, this is what the phenomena of gravitation is. So when you have two masses separated by some distance, they try to move towards each other due to an attractive force acting between them because of their masses. This is the phenomena of gravitation. So what Newton does is, he understood the phenomena of gravitation and he tried to formulate it. So he tried to derive at a common formula which can be used for any two bodies separated by any distance. Okay. So he tried to develop a formula or a relation which connects the force acting between two bodies and their masses and the separation between them. That is what is called as the universal law of gravitation. Okay. So we will directly jump to the laws proposed by the Newton. So what is the law of gravitation? So the force acting between these two masses is dependent on the product of their masses. It's directly proportional to the product of the masses. It is not individually dependent on any mass. It's dependent on both the masses. It is that the force acting between them is dependent on the product of both the masses. So it is not dependent on M1 or M2 alone. It's dependent on both of them. So it's dependent on the product of the masses of both of them. So force is directly proportional to M1 into M2, the product of the masses. Or the simple way of understanding this is, when you increase the product by certain proportion or by certain value, let's say by x times, the force acting between these two masses will also increase x times. So that's the simplest meaning of the proportion. Now the force is also dependent on the distance between them. So Newton observed, it's not just his observation. So from his experiments and from his observations, Newton also came to a conclusion that the force is not only dependent on the masses, it is also dependent on the separation between the masses. So at this instant, when we are viewing the two masses, let's say the separation between them is d, then the force between them at this instant is inversely proportional to the d square, where d is the separation between the masses at this instant of time. Okay, so we can combine both of these things into a simple relation or a single relation. So we can write it something like this: by d square. Force is directly proportional to m1 m2 by d square. When you combine both of these two things, this is what we arrive at. Okay, a relation connecting the force, the masses and the distance between them at any instant of time. Okay, so this is what's formulated by this is the relation at which this is the relation concluded by the Newton. And how did they equate these things? Okay, we are here at proportionality symbol, but so they found that based on the experiments and scientific reasoning, the force is related to them can also be written this way. Force is equated to the m1 m2 by d square. So force is equal to a constant. This capital G is something called as gravitational constant. So every time when you have two masses m1 and m2 separated by distance d and force f, this ratio f by m1 m by d square is equal to g. This ratio was always found to be the same. And that ratio is called as something called as universal gravitational constant, or you can simply call it as gravitational constant. So here the ratio of force acting between the two masses and this always found to be a constant, and that constant is called as universal law of gravitation. And why is this universal law of gravitation so important? Because it's a very, very, very simple topic, but very complicated things could be learned with the help of this universal law of gravitation. Okay, and G is called universal law of gravitation. Just a second. And what was the experimental value of the universal law of gravitation? Okay, throughout the lectures I will be using mostly the SI units, and the SI unit of the universal gravitational constant was found to be 6.67 into 10 power minus 11 Newton meter square per kilogram square. So this was the constant. So this was the constant G. This ratio was always found to be this constant capital G, and its G, the value of this capital G, was experimentally calculated as 6.67 into 10 power minus 11 Newton meter square per kilogram square. Here all the units are expressed in SI units. Okay, and I would like to conclude the video here, and in the next video we will try to discuss the more about this universal law of gravitation and how that force and the value of this universal gravitational constant, or simply called gravitational constant, is found to be 6.67 into 10 power minus 11 Newton meter square per kilogram square. Remember that this value is expressed in SI units. Okay, and most of the times it's common to get confused between the capital G, which represents universal gravitational constant, and another small g, which represents acceleration due to gravity. It's good to remember the differences between them. This represents the acceleration due to gravity of a planet, or acceleration of a body due to the gravitation of that particular planet. But this capital G represents gravitational constant, which is the same everywhere on each and every planet and at each and every point in the universe. But this small g, which is the acceleration due to gravity, depends on the planet. It changes from planet to planet, and for our planet on the surface of Earth, the value of this is found to be 9.8 meter per second square. It's better to remember the differences between these two things, which most of the times many get confused. And this is for today, and in the upcoming videos we'll try to discuss more subject and the concepts related to the gravitation. And if you think this video has helped you, make sure that you share it with your friends who are interested in learning. And also, if you like this, do not forget to like this video. And if you want to follow more videos, you can subscribe to my channel and learn from the channel. Have a good day.